Question 1. As illustrated by a growing enterprise environment, Fatima is responsible for maintaining high disk performance on a file server running multiple concurrent backup jobs during non-peak hours. She observes that despite enough CPU and memory headroom, the backup process slows significantly after 30 minutes of operation. She decides to use ISTAT and ITOP for investigation. ISTAT shows a high percentile consistently over 90% for Devster, while ITOP identifies a few large EO-heavy processors. What is the most appropriate initial step Fatima should take based on this analysis? A. Increase the swap space to prevent memory pressure during backups. B. Use IONIS to reduce the EO priority of backup processors. C. Replace Devster with an SSD drive immediately. D. Terminate non-backup processors to reduce EO load. Answer. Correct answer. B. Use IONIS to reduce the EO priority of backup processors. Explanation. Fatima correctly identifies that the bottleneck is disk EO saturation, percentile near 100%. Tools like ITOP reveal which processes are responsible. Using IONIS, you can adjust the EO scheduling class and priority, g. setting backups to idle without halting operations. This aligns with Linux EO scheduling policy. EFQ schedulers. Option A is irrelevant as memory isn't the constraint. Option C may help but is long-term hardware investment, not an immediate fix. Option D could harm other services. Refer to Linux Performance Tuning Guide and ManIONIS. Question 2. In the context of system recovery, Mr. Harper faces a boot failure on a custom-compiled kernel after a recent module update. The error message indicates that the root file system cannot be found. He suspects an issue with missing drivers in the initramps. What should Mr. Harper do to resolve the issue and prevent its recurrence? A. Reinstall grub to the MBR and reboot. B. Regenerate initramps using Dracut or mknipio including necessary modules. C. Manually mount boot and recompile the kernel with debugging enabled. D. Disable all kernel modules and only use monolithic kernel configuration. Answer. Correct answer. B. Regenerate initramps using Dracut or mknipio including necessary modules. Explanation. A missing root file system driver in initramps is a common cause of boot failure. Regenerating initramps ensures that required drivers, e.g. disk controller, are embedded. Tools like Dracut, mknipio, or update initramps Debian are designed for this. Option A concerns bootloader, not drivers. Option C adds unnecessary complexity. Option D defeats modular design and can reduce flexibility. Refer to LPI Objective 202.2, Initial RAM Disk Management and Mandraka. Question 3. From a practical standpoint, which of the following best describes the function of the proxysm swappiness kernel parameter and how should it be adjusted on a database server with large memory that prefers memory operations? A. Controls the aggressiveness of EPU frequency scaling. A lower value improves performance. B. Determines the EO scheduler policy used. Increase value for faster disk access. C. Controls the tendency of the kernel to swap out runtime processes. A lower value reduces swapping. D. Manages kernel log verbosity. Increase to capture more logs during high memory usage. Answer. Correct answer. C. Controls the tendency of the kernel to swap out runtime processes. A lower value reduces swapping. Explanation. Proxysm swappiness controls how aggressively the Linux kernel swaps memory pages. At low value, G10 instructs the kernel to avoid swapping unless absolutely necessary, ideal for memory-intensive workloads like databases. Option A is about cpufferec policies, not memory. Option B confuses swappiness with EO scheduling. Option D is unrelated. Refer to Linux kernel documentation, EAXD and systemvm swappiness. Question 4. Under the assumption that Ethan is reviewing long-term network usage trends on a Linux server to determine if upgrades are needed, the server has multiple NICs configured for redundancy using network bonding, which monitoring tool would provide persistent, graphical historical data to help him forecast bandwidth usage and identify anomalies over time. A. IFTOP emoji, CSS, D. Netstat. Answer. Correct answer. Emoji. Explanation. Emoji. Multi-router traffic grapher collects SMP data and plots it graphically over time, ideal for trend analysis. It helps predict capacity issues based on historical usage. IFTOP, SS, and NetStat are real-time or point-in-time tools with no long-term visualization. For forecasting and capacity plan, Emoji, Cacti, or Grafana with Collect Prometheus are standard tools. Refer Tuji documentation and LPI Objective 200.4. Monitoring tools. Question 5. To illustrate this point, consider that trans server frequently reports out-of-memory errors even though free shows sufficient total memory. She checks problem info and finds that much of the memory is consumed by page cache. What should she do to force the system to drop caches without rebooting, ensuring she understands the impact? A. Run sync echo 3 proc system drop caches. B. Increase VM. Swappiness to 100 to force swap and clear cache. C. Run kill all -9 on all services consuming high RAM. D. USCK on the root file system to clean unused blocks. Answer. Correct answer A. Run sync echo 3 prop system drop caches. Explanation. This is the safe, documented way to clear cache without rebooting. Sync flushes data to disk, and echo 3 clears page cache, entries, and nodes. This is useful for temporary cache bloating issues, but not a permanent solution. Increasing swap in SB affects swap behavior, not cache. Option C is drastic and unsafe. Option D is unrelated. Refer to Linux kernel documentation. ext and man5 proc. Question 6. Throughout the course of kernel module management, what is the correct sequence to troubleshoot a newly added kernel module foo code that fails to load with unknown symbol errors in dmesgate? Use insmod to force load and ignore symbol mismatches. B. Recompile the module with kernel headers matching the running kernel. C. Reboot into recovery mode and disable all modules. D. Remove libmodules and reinstall the kernel from scratch. Answer. Correct answer B. Recompile the module with kernel headers matching the running kernel. Explanation. Symbol mismatch errors typically mean the module was compiled against headers from a different kernel version. The correct approach is to recompile the module with uname. Are matched headers. Insmod A won't resolve unresolved symbols. Recovery mode C is unnecessary. Option D is overkill. Refer to LPI Objective 201.2. Kernel module management, Midinfo and Demas. Question 7. In light of recent developments, Lucas notices increased client complaints about slow service responses on a web server using SAR. In depth, he finds that one interface is nearing 95% utilization consistently. What network configuration strategy should Lucas evaluate to distribute load without adding new hardware? A. Configure RAID 10 on the network device. B. Switch to XFS file system to offload TCP load. C. Implement network bonding in round-robin or adaptive load balancing mode. D. Replace the Ethernet cable with a high-grade shielded cable. Answer. Correct answer C. Implement network bonding in round-robin or adaptive load balancing mode. Explanation. Linux bonding allows combining multiple NICs to balance traffic. Mode 0. Round-robin mode 6. Adaptive load balancing, improving bandwidth and redundancy. This is a software-based strategy with no hardware upgrade. RAID and file system are irrelevant. Cable quality affects noise, not bandwidth. Refer to Linux Ethernet bonding driver how to NLP. Objective 211.3. Question 8. Considering the evidence, which of the following commands is best suited to determine which processes are responsible for high network bandwidth usage on a Linux system in real time? A. Netstat. B. SS. C. IFTOP. D. tcdump. Answer. Correct answer C. IFTOP. Explanation. IFTOP provides a real-time interface-based summary of network traffic by process and IP, useful for bandwidth tracking. Netstat and SS show socket-level info, not usage metric. tcdump is packet-based and useful for protocol analysis, not bandwidth monitoring. Refer to LPI Objective 200.5, network monitoring and man-IFTOP. Question 9. From a historical standpoint, RAID 5 configurations have been widely used for balancing performance and redundancy. If Jamal wants to create a RAID 5 array across 3 drives using MDADM, what key limitations should he understand about disk failure scenarios? A. RAID 5 tolerates up to 2 simultaneous disk failures. B. RAID 5 offers no redundancy and is only for performance. C. RAID 5 can tolerate one disk failure, but rebuild time may risk array failure. D. RAID 5 increases available capacity by using striping with no parity. Answer. Correct answer. C. RAID 5 can tolerate one disk failure, but rebuild time may risk array failure. Explanation. RAID 5 can withstand one disk failure, but during rebuild, the risk of failure increases due to stress and uncorrectable read errors. Option A describes RAID 6. Option B is false. Option D omits parity, which RAID 5 uses. Refer to MDADA man pages, Linux RAID wiki, and LPI Objective 209.3. Question 10. In response to a sudden spike in CPU usage, Maria uses top and finds that a single process is consuming more than 300% CPU. A quad-core system. This process is multi-threaded. What conclusion can she draw about the nature of the workload and the Lin CPU scheduler? A. The process is overloading a single core due to lack of multi-threading. B. The kernel scheduler is malfunctioning and assigning too many threads. C. The process uses multiple threads across cores, each counted in total CPU percent. D. The process must be a zombie process stuck in a loop. Answer. Correct answer. C. The process uses multiple threads across cores, each counted in total CPU percent. Explanation. On multi-core systems, top rapport CPU edges, the sum across cores, e.g. 300% on a 400% system equals 3 cores. This is expected for multi-threaded apps. Option A misrepresents multi-threading. Option B lacks basis. Option D confuses process states. Refer to man-top procs and Linux CPU scheduling documentation. Question 11. From the perspective of system startup optimization, Rajesh notices that his Linux server takes an excessive time to reach the multi-user target. Upon examining the systemd logs, he finds several services waiting for network connectivity before starting. What is the best approach to reduce the boot time without compromising essential network services? A. Disable all network-related services and start them manually after boot. B. Use systemd's network online. Target dependency properly and parallelize services where possible. C. Revert to sysinit for faster service startup. D. Increase the timeout values for network services to avoid premature failures. Answer. Correct answer. B. Use systemd network online. Target dependency properly and parallelize services where possible. Explanation. Systemd allows defining dependencies on network online. Target, which indicates when network is ready, not just stuttered, properly configuring services to depend on this target, plus enabling parallel startup. System analyze blame helps identify bottlenecks, reduces boot time. Option A risks manual errors. Option C discards benefits of systemd. Option D delays boot unnecessarily. Refer to systemd documentation on targets and dependencies. Question 12. Given the circumstances when using vmstat to monitor, a server ANIC observes frequent high C swap-in and so swap-out values even though physical memory usage seems moderate. What is the most probable cause and suitable remediation? A. The server's CPU is overloaded. Add more CPU cores. B. The kernel is swapping due to high swappiness. Reduce VM. Swappiness value. C. Disk I/O is bottlenecked. Replace the storage device with SSD. D. Network bandwidth is saturated. Use cost to limit traffic. Answer. Correct answer. B. The kernel is swapping due to high swappiness. Reduce VM. Swappiness value. Explanation. High C and so indicate active swapping despite available memory, usually because VM. Swappiness is set high, default 60. Reducing swappiness to 10 tells kernel to avoid swapping, improving performance. EPU or network issues don't explain swapping. Disk upgrade might help, but only if storage is slow. Refer to Linux performance tuning and vmtap man page. Question 13. Within the framework of Linux kernel module management, Thomas attempts to unload a kernel module's ISE, but receives the error module's ISE is in use. What is the best method to identify which processes or modules are preventing this, and how should he proceed? A. Use lsmod to list dependencies and lsoft to find open files, then stop dependent processes before unloading. B. Force unload the module using RMO. F's ISE without further investigation. C. Reboot the system to clear all module usage. D. Remove the module file from libmodules and reboot. Answer. Correct answer A. Use lsmod to list dependencies and lsoft to find open files and stop dependent processes before unloading. Explanation. Lsmod shows which modules depend on XIS. lself-user can reveal processes using module resources. Stopping dependent service processes is necessary before safe unload. Forcing unload. B. Risk system instability. Reboot in. C. Is unnecessary downtime. Deleting files. D. Is ineffective until reboot. Refer to LPI kernel module management objectives and man pages. Question 14. Based on the information, during an audit, Emily finds that the server's logical volumes are running out of space. She wants to expand the logical volume LV data safely without downtime. What sequence of commands and considerations should Emily follow? A. Unmount the volume, resize the physical volume, then resize the logical volume. B. Use lvextend to increase the logical volume size, then resize the file system online with resizers or equivalent. C. Delete the existing logical volume and create new larger one. D. Reboot into single user mode, resize volume groups, then reboot. Answer. Correct answer. B. Use lvextend to increase the logical volume size, then resize the file system online with resizers or equivalent. Explanation. LVM supports online resizing of logical volumes and file systems. Exec FFS by FFS growths. The physical volume must have free space, but unmounting isn't required for online resize. Option A is disruptive. Option C causes data loss. Option D's are outdated. Always ensure backups before resizing. Refer to LVM and file system documentation. Question 15. When considering network troubleshooting, Sarah uses the ss command and wants to identify the state of TCP connections to a particular service. How does ss compare to netstat in terms of performance and detail, and what advantage does it provide? A. ss is slower but more verbose than netstat. B. SSU is kernel netlink socket, making it faster and more detailed than netstat. C. SS only works with IPv connections, whereas netstat supports IPv. D. Both provide identical output and performance, so no difference. Answer. Correct answer. B. SSU is kernel netlink socket, making it faster and more detailed than netstat. Explanation. SS communicates with the kernel directly via netlink, providing faster, more detailed socket statistics than netstat, which relies on PROGNIT. It supports IPv and IPv equally. Option A is false. C is incorrect. D ignores the technical improvements. Refer to MAN SS and Linux networking guides. Question 16. In terms of kernel runtime management, Ravi needs to temporarily increase the maximum number of open file descriptors system-wide to accommodate a high number of concurrent clients. What is the best way to achieve this without rebooting? A. Edit executabilimits.conf and reboot the system. B. Write the new value to Proxys file max using systl or echo. C. Recompile the kernel with higher file descriptor limits. D. Restart all network services to apply the new limits. Answer. Correct answer. B. Write the new value to Proxys file max using systl or echo. Explanation. The file Proxys file max controls system-wide open file descriptor limits at runtime. Using systl, WFS file max equals applies immediately without reboot. Option A. Affects per user limits and requires login logout, not system-wide. Option C is excessive. Option D is irrelevant. Refer to kernel documentation and systl man pages. Question 17. In contrast to traditional backup methods, Daniel wants to implement an incremental backup strategy using async on a Linux server. What is the conceptual advantage of incremental backups over full backups, and what must he ensure for data integrity? The incremental backups copy all data every time. Ensure disk space is abundant. B. Incremental backups copy only changed files since last backup. Ensure proper timestamp and checksum verification. C. Incremental backups require a full restore from scratch each time. D. Incremental backups delete all backups automatically to save space. Answer. Correct answer. B. Incremental backups copy only change files since last backup. Ensure proper timestamp and checksum verification. Explanation. Incremental backups improve efficiency by copying only change files, reducing time and storage. Correct timestamp, checksum validation, and consistent snapshot strategies are essential to avoid corruption. Option A describes full backups. Option C is false. Incremental backups allow point-in-time recovery. Option D describes retention policies, not backup type. Refer to Linux backup strategies and rsync documentation. Question 18. While examining system logs, Nia finds repeated errors indicating kernel panic. Not syncing VFS. Unable to mount rootfs. Which of the following diagnostic steps should she take first? A. Check the initramps image for missing drivers or incorrect root equals parameters. B. Reinstall the entire OS as kernel is corrupted. C. Disable Selinux temporarily to prevent mount failures. D. Remove all third-party kernel modules. Answer. Correct answer A. Check the initramps image for missing drivers or incorrect root equals parameters. Explanation. The unable to mount root FR panic usually means the kernel cannot access the root file system due to missing drivers or wrong root device parameter. Verifying and regenerating initramps with correct drivers and kernel parameters is first priority. OS reinstall is drastic. Selinux issues cause access denials, not mount failures. Removing modules blindly D may break functionality. Refer to kernel boot troubleshooting in initramps documentation. Question 19. Considering the evidence, Malik observes that the system's memory usage remains high even after stopping major services. Using free and VMTAP, he suspects the kernel is holding onto memory through slabs. What command and approach should Malik use to diagnose and manage kernel slab memory? A. Use slabtop to identify slab caches. If safe, echo values to proc system drop caches. B. Use top to kill processes consuming slabs. C. Increase swap space to relieve slab memory pressure. D. Disable kernel modules that allocate slabs. Answer. Correct answer A. Use slabtop to identify slab caches. If safe, echo values to proc system drop caches. Explanation. Slabtop provides real-time info about kernel slab allocator usage. Slabs can consume memory for caches. Dropping caches, echo 2 or 3 to drop caches can free memory, but only if safe to do so. Tilling processes B. Won't affect slabs directly. Increasing swap C. Doesn't address slab memory. Disabling mod D. May break system. Refer to kernel memory management docs and slabtop man page. Question 20. Throughout the course of performance monitoring, Eva uses SAR to analyze CPU utilization over time. She notices that %weight is consistently high, but CPU edge %user and %system is low. What does this indicate, and what should she investigate? A. EPU is idle because processors are waiting for EO. Investigate disk or network EO bottlenecks. B. EPU overheating is causing throttling. Check temperature sensors. C. EPU is executing kernel interrupts excessively. Check her balancing. D. System is swapping heavily. Monitor swap usage. Answer. Correct answer. EPU is idle because processors are waiting for EO. Investigate disk or network EO bottlenecks. Explanation. High % means CPU waits idle for EO completion, often indicating slow disk or network responses. Low % and %system confirm EPU isn't busy computing. Options B, C, and D don't directly explain high I weight. Monitoring tools like IOSTAT and IOTOP can help locate bottlenecks. Refer to Linux performance analysis and SAR documentation. Question 21. The primary reason for Ista Anders to use collect alongside Nagios in a Linux monitoring setup is to A. Perform active checks on system services and send alerts immediately. B. Collect and store detailed performance metrics over time for trend analysis. C. Replace Nagios completely for monitoring and alerting purposes. D. Automate system configuration management via scripts. Answer. Correct answer. B. Collect and store detailed performance metrics over time for trend analysis. Explanation. Collect is designed to gather, aggregate, and store system performance metrics, CPU, memory, disk IO, network. Nagios focuses primarily on active monitoring and alerting. Thus, they complement each other. Collect feeds data into graphing tools while Nagios handles alerting. Option C is incorrect because collect does not provide alerting. Option D relates to configuration management tools like Ansible, not monitoring. Refer to Nogios and collect documentation. Question 22. Given the circumstances, Mia needs to safely upgrade the Linux kernel on a production server with minimal downtime. Which of the following best practices should she follow? A. Directly replace the current kernel binary without backing up old kernels. B. Install the new kernel alongside existing kernels and update grub to allow boot selection. C. Remove all existing kernels before installing the new one to save disk space. D. Edit xstep to point to the new kernel image. Answer. Correct answer. B. Install the new kernel alongside existing kernels and update grub to allow boot selection. Explanation. Installing the new kernel alongside existing ones ensures fallback options if the new kernel fails. Grub bootloader configuration allows selecting kernels during boot, removing old kernels. C. Removes the fallback and is risky. Kernel binaries are not managed via xstep. D. Replacing without backup. A. Is unsafe. Kernel upgrade best practices in grub documentation. Question 23. When evaluating the merits of the Logical Volume Manager (LVM), which statement best reflects its advantage over traditional partitioning? A. LVM allows resizing logical volumes dynamically without repartitioning disks. B. LVM eliminates the need for any physical storage devices. C. LVM automatically encrypts data for security. D. LVM replaces RAID and file system functionalities completely. Answer. Correct answer. A. LVM allows resizing logical volumes dynamically without repartitioning disks. Explanation. LVM abstracts physical storage into flexible logical volumes that can be resized, created, or deleted dynamically. It complements file systems and RAID, but does not replace them. Encryption is handled separately. G. Lux. Option B is false since physical devices remain essential. Option D. Misrepresents LVM's role. Refer to LVM administration guides and Linux storage management. Question 24. Among the various network troubleshooting tools, which one would provide the most detailed packet-level analysis useful for diagnosing complex protocol issues? They. Ping BTC dump C, netstat D, iftop. Answer. Correct answer. BTC dump explanation. EE dump captures and analyzes raw network packets, allowing detailed inspection of protocols and headers. It is essential for diagnosing complex network issues. Ping tests connectivity but lacks detail. Netstat shows socket stats, not packets. Iftop shows bandwidth usage but no packet details. Refer ECDump man page and network analysis guides. Question 25. Based on recent studies, Sarah's Linux server is experiencing intermittent kernel panic errors. She suspects issues with faulty hardware drivers. Which kernel troubleshooting tool or method should she use to collect detailed kernel logs during boot to diagnose this? A. Dmesg command post-boot to view kernel messages. B. Configure and enable kdump to capture kernel crash dumps. C. Use top to monitor processes consuming CPU. D. Disable Selinux to avoid security-related panics. Answer. Correct answer. B. Configure and enable kdump to capture kernel crash dumps. Explanation. Kdump captures kernel crash dumps VM core on panic, useful for post-mortem analysis. Dmesg shows live kernel logs, but not detailed crash dumps. Top and Selinux management are unrelated to kernel panic diagnostics. Refer to kernel crash dump, kdump documentation and troubleshooting guides. Question 26. When analyzing EPU usage, John observes that a specific process shows 400% CPU utilization on an 8-core Linux server. What does this indicate about the process and CPU usage reporting? A. The process is using multiple threads running concurrently on multiple CPU cores. B. The process is monopolizing a single EPU core and slowing the system. C. EPU reporting is broken. Usage above 100% is impossible. D. The process is stuck in an infinite loop and causing kernel panic. Answer. Correct answer. A. The process is using multiple threads running concurrently on multiple CPU cores. Explanation. Linux top or HTOP will report CPU age, a percentage of total CPU cores. On an 8-core system, CPU age is 800%. 400% means the process is using the equivalent of 4 full cores. Options B, C, and D are incorrect interpretations. Refer to Linux Performance Monitoring Guides and Mantop. Question 27. Within the framework of disk I/O monitoring, how does ITOP differ from ISTAT, and in what scenario is ITOP preferred? A. ITOP monitors individual process I/O in real time, whereas ISTAT reports aggregate device statistics. B. ITOP only monitors network I/O while ISTAT monitors disk I/O. C. ITOP is a deprecated tool. ISTAT is recommended. D. ITOP summarizes historical I/O trends. ISTAT shows live data. Answer. Correct answer A. ITOP monitors individual process I/O in real time, whereas ISTAT reports aggregate device statistics. Explanation. ITOP shows which processors consume I/O resources live, helpful in identifying I/O-heavy processors. ISTAT reports device-level I/O metrics. Throughput utilization. Option B is false. The ITOP does not monitor network. Option C is incorrect. Option D reverses their functionality. Refer to man pages and Linux performance tuning resources. Question 20. In a scenario where a network interface is configured for bonding, which of the following is a critical factor to ensure proper load balancing and failover? A. Matching switch configurations to support bonding modes like LAC. B. Using RAID 1 on the bonded interfaces. C. Disabling IP to avoid address conflicts. D. Assigning static IP addresses to each bonded interface member separately. Answer. Correct answer A. Matching switch configurations to support bonding modes like LAC. Explanation. For bonding modes like 802.3 and LAC, the network switch must be configured to aggregate links accordingly. Without this, bonding may fail or fall back to suboptimal modes. RAID. B applies to disks, not network. IP. C is unrelated. Static IPs. These should be assigned to the bonded interfaces, a whole, not members. Refer to Linux bonding driver documentation and switch manuals. Question 29. Considering the evidence, which kernel parameter is most appropriate for tuning to reduce system latency in a real-time multimedia streaming application? A. Increase VM. Dirty ratio to allow more dirty pages. B. Lower kernel. Shed latency NS to improve scheduler responsiveness. C. Set VM. Swappiness to 100 for aggressive swapping. D. Disable ERC balancing to reduce overhead. Answer. Correct answer. B. Lower kernel. Shed latency NS to improve scheduler responsiveness. Explanation. Kernel. Shed latency NS controls the scheduler's time slice length and responsiveness. Lowering it reduces latency, important for real-time applications. Increasing VM. Dirty ratio A can increase I/O latency. Setting high swappiness. C causes unnecessary swapping. ERC balancing. D usually improves performance. Refer to Linux kernel scheduler tuning guides. Question 30. For the purpose of capacity prediction, Hannah wants to anticipate when her server will run out of disk space based on current usage growth. Which tool or method provides the best approach? A. Use DF daily and manually calculate growth rate. B. Use monitoring tools like Nagios or Isinga combined with graphing tools for historical trend analysis. C. Use mount command to check disk usage. D. Run SCK regularly to check file system integrity. Answer. Correct answer. B. Use monitoring tools like Nagios or Isinga combined with graphing tools for historical trend analysis. Explanation. Monitoring systems with data collection and graphing can track disk usage trends over time, allowing forecasting of when capacity will be exceeded. Manual DF checks. They are error-prone and inefficient. Mount C shows mount points, not usage. SCK D checks file system health, not capacity. Refer to monitoring best practices and tools documentation.